So I told you to go ahead and write this down when you were watching the video. That's now posted on your Google Classroom. If you want to print a copy of that sometime, you can go to the Media Center and print one of these, or you could go to, or do it at home, whatever, if you want one. If you're happy with the one you have written in your notes, that's perfectly fine too. Now, that is one of the big things. The two big things, what do you think the two big things from this video were last night? Austin, what was one of the two big things? Scientific notation. What scientific notation is, how to do it. I would imagine that you've ran into scientific notation before, correct? Okay, so this should just be a review for us. Now, the second part of this video, the second main point of the video was what? Mackenzie. Units of measurement specifically dealing with the metric system, right? That is what I just showed you, the metric system. Now, as I said before, and I don't know whether I said it in this class or another one, we're pretty familiar with King Henry died by drinking chocolate milk. You know, those ones, from kilogram down to milliliter. But are you as familiar with giga, okay, tera, nano, alto, pico, micro, stuff like that? Probably not. So we're going to expand our knowledge a little bit based on our chart that I just had before. So what we're going to do here as we review our notes from yesterday, what we're going to do is just work more examples. So the very first example that we're going to go over of this scientific notation is up on the board. It says, convert the following numbers into scientific notation. Yeah. Okay, what we're going to do is we are moving the decimal, correct? And when we move the decimal, the number's got to be in between what? Okay? We want a number that is in between 1 and 9, correct? So, as I do this, my number is going to be in between 1 and 9. It's going to be 2.3. That's in between 1 and 9, isn't it? Now, how many places now did I move my decimal? Jumped at 1, 2, 3, 4, 5. So I know it's going to be times 10 to the 5. Does that 5 need to be positive or negative? Is that 10 to the 5 or is that 10 to the negative 5? Yeah, Dina? Negative 5. Why is it negative 5? Because that number is less than 0, isn't it? Okay? Or less than 1, I'm sorry. It's not less than 0, it's less than 1. So, correct answer, 2.3 times 10 to the negative 5. Now, what you're going to learn tonight, okay, because our assignment's right here on the board, we're going to review notes, scientific notation, units of measurements. You're going to get some notes today. I'm going to hand out notes on sig figs. What you're going to find out about significant figures and scientific notation is that when we have scientific notation, all of the numbers in front of the times 10 to the whatever are significant. Okay? All of the numbers are significant. So in this particular problem, we would have two significant figures. Here's my next one. Here is my next problem. So I need to move my decimal point to get a number between 1 and 10. I'm going to do so by making it 1.01. Why didn't I put all 3 of these zeros here? Solomon? Huh? They are not significant. Those are back zeros behind. Those are placeholders. What you're going to see is any pinched zero. Okay? It's squeezed in by 2 non-zero numbers. That means that that is significant. So that first 0 here will be significant, but the trail zeros will not be significant. So I have my 1.01, my times 10. I have to determine how many places that I move that decimal. Where's my decimal point? I don't have one, do I? Where's it at? Where's it at, Skylar? Behind the last 0. So I moved it. How many? 5, right? Final answer. 1.01 times 10 to the 5th. Now convert the following numbers into standard notation. So we're working this the opposite way. We're working this guy the opposite way. So I know that I have 4 for my exponent. So I am jumping my decimal 4 places. Since it is positive, which way am I jumping my decimal? Which way, Maggie? To the right. Excellent. So, since it's positive, I'm jumping it to the right. 4, 1, 2, 3, 4. So I need to add 2 zeros. 2, 3, 0, 0, 0. I can put that comma in there. Now, you don't know this yet. You don't know this yet. But if I'm looking at that, that is only 2 sig figs. How many sig figs do I need? How many sig figs do I need? Well, I just told you that any number in front of the times 10 to the x, any number in front of that is significant, right? How many sig figs do I need? 3. This right here, 23,000, is only 2. So I have to signify that this 0 right here is significant and that these 2 back end ones are not. So what I'm going to do is I'm just going to put a bar on top of that. That bar tells me that that 0 is significant, that these back 2 zeros are not significant. Okay? Do we understand that bar? Now, if I were doing something like this, and this is why we're learning significant digits, okay? Because when you do WebAssign, when you do your first WebAssign assignment, do you think you can put bars over zeros on WebAssign? You can't. So the only way that I will be able to signify 23,000 like that with 3 sig figs is to put it into scientific notation. Okay? I'll have to put that into scientific notation because I can't put a bar like that into WebAssign. Okay. Number 4 there. 1.901 times 10 to the negative 7th. First of all, how many sig figs do I have? 4. Okay? Real easy with scientific notation. All those numbers in front are significant. So I have 4 sig figs. Now, I know that I am jumping it 7 in the negative direction. What direction is the negative direction? Taylor? Negative direction is the left, so I'm going this way. So I'm jumping this 7 spots. 1, 2, 3, 4, 5, 6, 7. Boy, I ran off the board there. Okay, ran off the board. So I have my 4 significant digits, and I jumped it, what did I say, 7, 1, 2, 3, 4, 5, 6, 7. I got to fill in that many zeros. One, two, three, four, 5, 6. Now, all of those zeros, those front end zeros, those are all considered placeholders. They are not significant digits. So by showing this value, 0.0000001901, I have 4 sig figs. Yeah, Austin? Here? You don't need that, okay? You don't need that because these are what we call sandwich zeros. Any sandwich zero in between non-zero numbers are significant, okay? We already, you'll see that when you read your notes tonight. Okay, sandwich zeros are significant. Any questions on the scientific notation here? All right. Now let's show some metric conversions. Now, when I'm doing metric conversions, okay, when I'm doing metric conversions, I'm going to use this guy right here. All right? I'm going to use this guy right here. And all I need to know is how to read my chart. If I am going up my chart, if I am going up my chart, I am jumping my decimal to the left. If I am going down my chart, I'm jumping my decimal to the right. So up the chart, left, down the chart, right. Now, key things. What I use when I am doing this, okay? Oops, I don't want to do that. That's not what I wanted to do. I wanted to bring this down, okay? All right, so when I am doing metric conversions, I'm looking at this place right here. Okay? I'm looking at that place right there because I'm looking at the exponents. Okay? I see hecto right here. Hecto has an exponent of 2, right? Let's say I'm going from hecto up to mega. Mega has an exponent of 6. Well, how many jumps to get from 2 to 6? 4 jumps, right? That's 4 jumps. What way am I going? I'm going up, so that tells me jump it left. So if I'm going from hecto to, what did I say, mega, I jump the decimal 4 to the left. Nice and easy. Okay? Let's say that I'm going from hecta and I'm going down to milli. I have hecta, I'm going down to milli. How many jumps did I make there? How many jumps? I jump from 2 to 1, 1 to 0, 0 to -1, to -1 to -2, -2 to -3. So I made 1, 2, 3, 4, 5 jumps, right? Right? That's where it gets a little confusing when I go from a positive, negative number, okay? I jump 2 to get to 0. This is how I think of it. I go down 2 to get to 0, then I go down another 3. I went down 5 total. What way did I go? Down, so I move my decimal what way? To the right. Now, if you haven't noticed, when you look at your chart, it would be nice, and it would be great, and it would be easy if it was just 1 in between every number. Okay, but when I get down here, I've got -3, then -6, then -9, then -12, then there's 3 jumps in between those. Okay, 3 jumps in between those. So don't get confused with that. Now, as I go back here, I have millimeters, I'm going to kilometers. That's an easy jump for us. That's an easy jump for us because I know King Henry died by drinking chocolate milk, but I have millimeters, I'm going to kilometers. How many jumps do I make? How many jumps? 3 to get to 0, another 3. How many total jumps? 6 total, right? So I jump it 6. 1, 2, 3, 4, 5, 6. What way? To the left. So I come back here. Once again, where's my decimal point? Behind the last 0, 6 to the left. 1, 2, 3, 4, 5, 6. My new number is 6.356 kilometers. Why did I not put those last 2 zeros there? Lane? They are not significant. You will learn that. They are not significant. That's tonight's notes. The next one. Hectometers to gigameters. And my abbreviation for giga is capital G, so this is GM. Gigameters. I have hecto. I want to go to giga. So I find my hecto. Right here's hecto. Hecto is a 2. I want to go to giga. Right here, giga. Giga is a 9. How many jumps to get from 2 to 9? Don't everybody scream it at once. How many jumps from 2 to 9? Trent? 7 jumps. What direction am I jumping? I'm going to the left because I am going up. So I am going to jump this 7 to the left. 1, 2, 3, 4, 5, 6, 7. My new number is 0.8523 gigameters. You okay with that? Why don't we do this? Why don't we do this? I've got 2 more problems. I want you to do these 2 problems, and then I will work them on the board when you are done doing them. All right, here we go. We're back onto this millimeters to micrometers. Okay? Millimeters to micrometers. I find milli right here, -3. Micros right below it at -6. So I am jumping my decimal 3 places. In what direction? The right. Come back 3 places to the right. 1, 2, 3. So I have my new number being 0.934 micrometers. Any questions over that one? Okay. Now I have nanometers, NM, nanometers to decimeters. Nanometers to decimeters. I find nano right there. Nano is -9. Decimeters is -1. So how many jumps am I making? 8 jumps. What direction? 8 jumps to the left, right? 8 jumps to the left. Here's my decimal. 1, 2, 3, 4, 5, 6, 7, 8. Point 30456 decimeters is my final answer. Okay. So if you have the availability of that chart, you should be able to use that by counting how many jumps based on the exponents related to the 10 to the whatever. Okay. We have thumbs up? We okay? Front row? That's how I do my check. Give me a thumbs up so I can check everybody's good. We good? Front row? Middle row? We thumbs up on metric conversions here. Back row? Thumbs up? Awesome. Excellent. Great.